Well, hello, welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith here in Reading, England. On the bench today we've got an Engl, and it's a tube power amp 840/50. This is a stereo 50 watt power amplifier. Valve uses two 6L6s per channel and basically two amplifiers in one box. No pre-amplification to speak of, so it's just a kind of dual 50 watt power amplifier. The customer said that he was using it and he smelt something very hot, not quite burning but very hot, so he turned it off. Then a while later he tried it again and it seemed to work okay, so he's a bit unsure about what happened there. So I think all we'll do is take the lid off and have a look, see what's going on inside this amp. I've never seen one before, so I'll be interested to have a look. So let's get the lid off and have a look inside. Okay, the last screw out, and let's have a look what we've got inside here. Ooh, okay, interesting. Let me show you what's inside this beast. So we have four 6L6s, so it's a dual 50 watt amp this, 50 watts a side, so a pair for each of the channels. A couple of skinny looking output transformers, nothing special for 50 watts, only just capable of that I would have thought. Great big power transformer and three preamp valves. I don't know what they're doing. This is not a preamplifier in the sense of you know, a guitar amplifier. It needs a preamp to feed it, so these are probably two phase splitters and maybe one tone control or something like that. Well, this might be. Anyway, having a little look around, if you remember he said he smelt burning, and there is absolutely nothing here which looks like it's burned out. A common thing might be these. I think these are the screen resistors here. I'd have to check. Anyway, 470 ohms almost certainly. They are all okay. That would be a likely candidate for a nice puff of smoke. Actually, is that one? No, that one's okay. No, I thought that was maybe damaged. Okay, we've got two fuses here. We may as well check those. He did say both channels were working. I'm guessing this could be the two bias pots, one for each side. Are they HT fuses? I would guess so. 300 milliamps. Four diodes there, which are obviously doing the rectification for the AC to produce HT. Three diodes here, could be bias. Don't know why there are three. A relay. Not sure what that's doing. Oh, and another relay. So there's obviously some kind of probably when you press these buttons here, maybe the relays come in. Right, well, the other thing I'm going to do is stick my nose in there, because even though it's been several days since the burning smell, that does tend to persist, and you can normally smell if something has cooked. Other than that, I think the first thing we'll do is just check those fuses and yeah, see what else we can find. Absolutely no smell of burning at all. I've also had a good visual inspection with my eyeglass, and I cannot see anything that's gone up in a puff of smoke there. So that's a bit of a mystery. Right, well, let's just check these two fuses. How do these things come out? Oh yeah, there we go. There's one, it says 315 milliamp. That's a kind of HTE sort of fuse in my view. That one's okay, as I expected. Be very surprised if this one's gone. Hello, hello, hello. Hello, hello. This one. This fuse has blown. Have a look in my eyeglass, and yes, definitely blown. Well, that's odd, because he said both channels were working, and that cannot be the case if that fuse is gone. Right, what shall we do here? I think I'm going to pull the power valves, put a fuse back in and turn it on and see if the fuse blows. Then I'm going to test the power valves and take it from there. So one, should have had my Weetabix this morning. Okay, there's those three. Let's see if we can find ourselves a 315 milliamp fuse. Then we'll turn it on and see if it goes pop. I'm sure I've asked this before, but and I'm sure maybe someone's told me, but the fuse values are weird, aren't they? You know, 315 milliamps. Where did that come from? Very odd. Very odd fuse value. Why not 300 milliamps? There's obviously something behind that. 6.3 amp is another fuse. Why not 6 amp? Where's the 6.3 come from? Right, so popped a fuse back in there, the correct one. Power valves are out. I think I'm just going to power it up really, and see what happens. So plug it in. What that is, turn it on. It's out of standby. Oh, there we go. Yeah. And ooh, it's making all sorts of whirring noises, and LEDs are lighting and stuff. Must be good. It's got LEDs. Fans going round. Fuse, I can see quite clearly, is intact. There's nothing wrong on the board in terms of blowing the HT fuse. Okay, right, well, let's turn it off, and I'm now going to test these valves to make sure they're okay. Right, I've put all 4 of these tubes on my tube tester, and they are all okay. However, spot the difference between these 4 tubes. Can you see that one there? That's got hot at some point and burnt the printing off, but they all test okay. Right, so another thing I want to do is actually to measure those screen resistors, because I have known them, rarely, but I have known them look okay, but actually they're blown. So let's just have a quick look. Should be 470 ohms. Yep, 450, 460, 450, 50. So the screen resistors are okay. Did one of these valves red plate? That certainly would have taken out the fuse and maybe created that kind of burning smell. So I think what I will do, I think I'm just going to eyeball the connections, the soldering joints on the underside of these tubes here, just to make sure they're okay. I'll do that with my little jeweler's loop here. So I'll do that and then let you know what I find. Well, I'm not thrilled by the quality of the solder joints, so I'm just going to go over all of these joints here and just eliminate a dry joint on the underside here. I mean, they're kind of okay. There's one. I'll do the other 3, and then I think it's time to put the power valves in and switch on and see what happens. Okay, I've done all the solder joints on there, so let's pop these back in. Yeah, I don't think it actually matters which order they go in. Okie dokie, well, I think I'm just going to switch on. Keep an eye on that fuse, keep an eye out for red plating. So here we go. They're out of standby at the moment anyway, so don't think much can happen. Heaters are all lit up, that's good. So let's take the left bank out of standby. I'll put it back in standby. Now the right bank out of standby. And back in standby. So nothing blue. Let's just leave them to warm up a second longer. Then I think we'll take both out of standby and keep an eye out for red plating. So here we go. 2 standbys off. We haven't checked the BIOS, of course. You can tell a lot what's going on with the amplifier just by testing the temperature of each valve. Obviously there comes a point where you can't touch them like this, but if one's getting significantly hotter than the others, of course we've no idea what's going on with the BIOS. What would be sensible to do next? I think it would be quite nice to know if anything's coming out of this amplifier. Yeah, there's no right or wrong order for doing all these things. The next logical step might be to BIOS it and see what's going on the BIOS front. But I think I'm quite interested to see what's whether the amplifier is producing any noise. So I'm just going to plug a speaker into one side and a signal into the front and see what happens. So there's a loudspeaker on the left channel, and we're going into the left channel and we're hearing a nice loud signal, so that's working. Let's just swap them over to the right hand channel. Oh yes, okay, the right volume was down compared to the left, so again, yep, got a nice signal there. So this is basically working, this amplifier. So I think what I want to do now is get some BIOS meters on this, turn it off and let it cool down a bit. Okay, I've put the BIOS probe on the 2 inner valves and I had to remove the fan to get the BIOS probe in there. Wasn't enough room with the fan in. And I don't know whether you can read this, but basically we've got 36 milliamps on both. Actually, they're very accurately matched. And what I found is that the one pot does 1 meter and one does the other. So for example, if I turn this pot here, maybe I'll do the other one. This pot here does this one. Look, that's gone up to 38, 37, bring it back down to 36, and this pot does this one here. So that means, of course, that this is a pair and this is a pair, which makes sense. That's how I would do it. So now with 36 milliamps here, I think I will turn the amp off and check the outer pair of valves to see what they're doing. Make sure that they're all pulling a sensible current. Okay, I've swapped the valves to the outer positions now, and that's interesting. I'm getting a... Yes, I do remember when I tested these valves that one was a bit different from the others. I wonder if it's that one with the the red plated. Anyway, we're getting 39 milliamps and 30 on this outer pair. So we need to take a view on what we do with that. I could, for example, just adjust the bias to make this 32 and this 37, which is okay, which will slightly mismatch those two as well. I think that's probably what I will do. But let's just check. Shame that the printer's all on the other side. I'm just going to turn this off, and I want to check where that valve that had red plated. Yes, it's this one here. Okay, so that's useful to know. So that was this one. Just turn it on again. So this is the valve that had red plated. hard to read this meter. I don't expect you to be able to see it, it's quite dim. Just about see that, I think. So 38, and so this is yeah, it's interesting. The one that's red plated is gone a bit low current. As I say, we could just tweak the bias on this such that, let me see, we've got 40 there. That's this one, yeah. Yeah, we make that like 37 or something. This is 31, so maybe, yeah. And just kind of spread the errors around. So this is like 36.8, that's 31, which means that these middle pair now will be, I don't know, 34 and 37 or something. And yeah, so for me that's good enough. Especially now with prices being what they are, a set of valves for this is going to cost you £100. So I will obviously ask him if he wants me to change the valve, but in my view, that, yeah, 5 milliamps is a reasonable amount, but not absolutely crazily mismatched. Don't forget that when an output pair or quad is mismatched in the bias current side of things, you get a little bit of distortion on the sine wave or on the signal. And of course, guitar amplifiers, they're just distortion generating machines. Nobody cares about a bit of extra distortion. In fact, they might even like it, and you actually wouldn't even hear it anyway. Now, if this was some sort of very fancy hi-fi amp, you would want these matched to within a half a milliamp if you possibly could. But with a guitar amp, it really doesn't matter at all. You obviously just don't want to make sure that one valve is pulling a load of current and one valve is pulling hardly any, such that this valve gets really hot and this one runs cool, and then that has an effect on the tube life and that sort of thing. But a few milliamps difference, don't sweat it. When you're biasing amps, if you can get them the same, get them the same. I always do. But if you can't, look, 33 and 37, perfectly okay. So I'm going to suggest to the customer that he doesn't blow £100 on a new set of valves, and I don't know what happened to this amp, why it got hot. I think that valve red plated. That would account for the strong burning smell. It may have been a dry joint on the underside. You know, maybe it was the bias not getting through or something. But there's no obvious sign now of this failing. Put the valves back in properly. Contact the customer. Put the fan back in. Put the lid back on and see if that hum disappears a little bit. And then we'll give it a test to see what power it's producing. Make sure the sine wave looks quite nice, and then call it a wrap. I just thought I'd show you a quick workshop tip. Putting this fan back here is held in by these 4 nuts and bolts, and the bolt that goes in the bottom here, you can't get the nut onto it, it's just impossible. So a little thing I've done sometimes to get me out of trouble is to take a little blob of glue, it doesn't really matter what glue, a little bit of Bostik there, and I can just about get the tip of my finger to the end of that screw. So I just glue the nut onto the end of my finger like that. I leave it a couple of minutes, and now I can get in there and just touch that nut on the end and do it up with a screwdriver. And then of course once it's on a few threads we're home and dry. So let's see if we can do that. Now it's quite tricky, quite delicate. Yep, that's on okay. And yep, worked first time. So just do that up a couple of turns. And now of course I can get some long-nosed pliers in there to hold it, to do it up properly. So that's a little trick I've used many times to get into very hard to reach places where you need to get a screw in or get a nut on the end of a screw and on the end of a bolt, that sort of thing. So that's yep, that's done up nicely, that. So I've got to repeat that performance with this other bolt at the end here, and I'll just get in there with my finger as well and do the same thing. Anyway, if you haven't seen that before, I thought you'd enjoy that. Right, I've had a word with the client and he does want the valve changed. That's the one that had got hot. And I've looked through my second-hand valve box, and amazingly I have a single Engl 6L6 GC to match those, and it's the same current as those, so I happen to have a exact match used Engl 6L6. So that was good, so I can save the customer some money there, because new valves are very expensive at the moment. So they're all now back in properly, and the next thing is, I think, just to put the lid on. It's got an earthing strap here which connects to the lid here, and I'll put the lid on and fire it up again, make sure it's all still working, and I think we can call it job done on that. Bit of a mystery about exactly why that fuse went. Was it a dry joint? I suppose it could have been a valve. Could have been that valve actually went faulty, but it wasn't really faulty, it was just pulling a different current to the others. So I'm afraid jury's out at the moment, nothing obvious. Let's get it back together again and just double check that it all works. Okay, lid back on, all switched on, and turn up the signal generator. Yep, that's nice and loud. Okay, it's got some sort of switched volume control, don't know why. So this volume control controls it now. If you switch here, it switches to this B volume control. Can't think of a useful use for that, but then maybe that's just me. So now we'll just swap the speaker and the input to the left channel and make sure that's working. Here we are on the left channel now, and this is the volume that's working. Switch the volume, and that one works. Wonder why they want that. Can't imagine. There's a kind of a gain button there that puts in some more, and some tone control here. This will be what those preamp valves are for. This presence control. Again, you've got this kind of switchable bit. You can have the A setting or the B setting. A peculiar thing. Oh well, there you go. Anyway, it's all working. Okay, well, I hope you enjoyed having a look inside that amp. I've never seen one before. I enjoyed having a look. A bit inconclusive, I think, the repair. What was it that was burning or smelling hot? Was it that power valve red plating? It certainly looked like it had red plated because you could see the printing had burned off, but there's no obvious reason for the red plating. No burned out screen resistors, nothing obvious there at all. I went over all the joints on the bases, some of which were a bit iffy, so was it that? I don't know, a bit of a question mark still over this amp. But anyway, it all seems to be working okay now, so I think send it back to the customer and he can test it in situ. Well, as ever, thanks for watching. I'll see you on the next video.